Today we start a really big branch of mathematics, algebra specifically, which is solving equations. And I want to start out by telling you some big ideas about them. What makes an equation is an equal sign. And an equal sign, as you know, connotes that two sides have the same value. An algebraic equation is an equation that has a variable. So if I say to you x plus 5 equals 12, at this point, of course, you know what x equals. But before we go there, just understand this is one side of the equation, and this is another side of the equation. And if you think of them like a seesaw, they balance each other out. Since the only way to make x plus 5 equals 12 is to have x equals 7, 7 is the solution. Solution, which is more important than you can imagine. It's the solution because when you plug it in, it makes it true. When plugged in, the equation is true. That's what makes it the solution, and you can check it by plugging it in. 7 plus 5 does, in fact, equal 12. This leads us to some big ideas when we're knew that the answer to that was 7. So clearly, our study is not about finding answers. What we are doing instead is developing a very specific and precise method of working our way through more and more complex equations. But even though they're complex, the big ideas remain the same. So, the big ideas are this. First, you're always trying to isolate the variable, which means, in simple terms, get it alone on one side of the equation. And if we're thinking about a seesaw, if I subtract 5 from one side of the equation, I have to also subtract 5 from the other side, or else it's not equal anymore. So, the second big idea is whatever you do to one side, you have to do to the other to keep it equal. There's a corollary, or another idea, that I wouldn't exactly call a big idea here, but it goes with both of these. Let's go to our example. X plus 5 equals 12. Well, if I'm trying to isolate the variable, I first have to find the variable. Then I say, what is going to get rid of plus 5? If I want to undo plus 5, I subtract 5. And I find out that x is equal to 7. On the other hand, if I said 3 times x is 12, here is my variable. I want to isolate it, get it alone on one side of the equation. What will undo 3 times x? 3 divided by that. So if I divide by 3, remember about dropping out the 1, that means that x is equal to 4. So the other little idea that goes with each of these is opposites undo. So keep these in mind as we travel on to our first type of equations involving addition and subtraction. We've already seen an example like this, but here's another example. Let's say x minus 3 is equal to negative 8. Remember the two big ideas. I want to isolate the variable, get it alone on one side. So first of all, I got to say, okay, here's my variable. I want to get this alone on one side, which means I've got to get rid of this. To undo minus 3, I add 3, because negative 3 and positive 3 equals 0. Whatever I do to one side, I have to also do to the other side. I draw my big fraction bar. I bring my equal sign straight down, because remember, like the seesaw, that's the thing that's the middle. The equal sign has to balance it. I'm left with x alone on this side of the equation and negative 5 on this side of the equation, because negative 8 plus 3 is negative 5. And you can always check your answer by plugging it in, because the solution to an equation means if you plug it in, it will make the equation true. Negative 5 minus 3 is, in fact, negative 8. Or if you need to remember to think of it as add the opposite, you can see it like that. There's your check, and you're done. What if I say x minus negative 2 is equal to negative 7? Well, this brings up a topic that we've had before. Subtraction is always adding the opposite. And so when I have minus and negative, we really need to remember to slash and dash. This equation is actually equivalent to x plus 2 is equal to negative 7. So I need to isolate my variable. Here's the variable. Here's what's on one, the else is on that same side of the variable. And the way I get rid of that is to subtract 2. If I do it to one side, I do it to the other. I draw my line, and I have x is equal to negative 9. And that is true, because negative 9 minus negative 2 is negative 7. So one of the things you'll find in this class is that I'm very particular that you show the work exactly the way that I am showing you. So now I'm going to do a few, shake things up just a little bit. And I want to continue to, this time I'm not going to show you, like, for example, if I say negative 8 plus x is equal to, I don't know, 15. So I need to isolate my variable on one side of the equation. To do that, I have to get rid of the negative 8. What gets rid of negative 8 is positive 8 when you're adding. If I add it to that side, I have to add it to this side. That cancels out because negative 8 plus 8 is 0. I've got x alone on one side of the equation. It is isolated. And that means that x equals 23. The check is negative 8 plus 23 is equal to 15, and that is, in fact, true. Notice, when this came first, the way I got rid of it was to add the opposite. This is still giving me positive x alone on one side of the equation. What if I say negative 4 equals x minus 6? Aha! Notice now, x is over here. I'm still trying to isolate x on that side of the equation. I have to get rid of minus 6. Opposites undo, so I'm going to add 6. If I do it to one side, I do it to the other. Draw my line, equals. Positive 6 and negative 4 is positive 2, and that equals x, and that's true because negative 4 does equal 2 minus 6, or 2 plus negative 6. Either way, that's the check. So there you have it. Equations in one step that have addition and subtraction.